Hi everyone, and welcome back to another Collodion chat. The series where I finally bought an actual video light. Only one so far, so doing my best with a single softbox today, but gonna add a few more to the collection soon, and hopefully we'll finally have some decent, consistent lighting throughout the video. You may have noticed in my previous videos where I just used my big old LED tubes in the garage here, that the color kind of shifts ever so slightly throughout the videos. So hopefully with some proper video lighting, that will not be a thing anymore. Anyhow, today I want to talk about glass, specifically glass cutting jigs. So, when I did the Collodion Basics series, kind of the one thing that I didn't really touch on is shooting glass, right? I didn't cover how to cut and how to prep and how to shoot on glass, primarily just out of convenience. I didn't want to show those extra steps, and I find that when you're just getting started, being able to just kind of pick up an aluminum plate and peel the cover off is a very quick, very convenient experience that minimizes the skills you need to work on to get started shooting. But a lot of us do shoot glass. I primarily shoot on tin, but I use glass from time to time. Sometimes I like to make an amber type. Sometimes I want to make contact prints, and I'm making glass negatives. So I want to talk a little bit about cutting glass today. And this isn't going to be an in-depth tutorial on how to cut glass. I think that is something that I'm probably going to address along with cleaning in a future episode. But today I just want to talk about how to expedite cutting glass, right? For those of us who are already familiar with how to work a glass cutter. So when you first start cutting glass, if you're like me, and I would assume most people, the way that you tend to do things is, you take your piece of glass and you measure out the dimension that you want, right? Maybe you make a little Sharpie mark, and you take hopefully a plastic square and you set it up against the edge, and you use that to kind of line up your glass cutter and make your cut. And that process has two big problems. The first is that it's not super accurate, right? You're going to make small mistakes in your measurement. You're not going to be perfectly consistent from cut to cut. And the second problem is that it's just slow, right? It takes a long time to make those measurements each and every time, especially if you're trying to be very careful to minimize that first problem, which is, of course, the inaccuracy. So if you're cutting a lot of glass, which I have at various times in the past, it can be really helpful to have some kind of a jig or a fixture to help you cut glass quickly and repeatably to the specific sizes that you want, kind of over and over again. So my glass cutting jig journey kind of started when Mark Osterman posted a video of a really, really lovely, really simple glass cutting jig that he'd made. And that jig was just a board, and it had two pairs of nails driven in it, right? One for 4 inches, one for 5 inches. And he would just lay a ruler across two of the nails. There's a fence on the bottom of the jig. He just butt a piece of glass up against it, run the glass cutter along its straight edge. Boom, he's got his cut. And he was using that to break 8x10 sheets down into 4x5 sheets. That works great, but I wanted to cut really big glass panes, right? I don't like, grabbing a bunch of 8x10 sheets. I'm gonna be shooting 4x5. I would rather go to Home Depot, get one great big pane of glass, and then just cut it down into strips. And that way I get a better unit price on my plates. So I made this gargantuan glass cutting jig out of like a 1/4 sheet of MDF. It had this big long fence along the bottom. And then because I couldn't put nails close enough together for 4 inches and 5 inches with the width, the straight edge that I needed, I ended up doing this whole thing with removable holes and dowels that went into them. It was a mess. It didn't help that I knew absolutely nothing about woodworking at the time, and I was just kind of doing my best, right? But that worked. It wasn't great, but it worked. But it's very large, it's very cumbersome. And so I've been wanting to make a better, more effectively adjustable glass cutting jig. And I've also wanted to make a video about making that jig. So I've been planning this for a while. Not seriously, but just kind of in the back of my head, running through ideas. So I worked through various woodworking plans with sliding dovetails and thumb screws to set a straight edge into place, and pre-prepared spacers for different sizes. And it was turning into this whole big kind of extensive project in my head. And at some point I thought, you know, this is going to be a woodworking video. I know some of us out there have kind of well-equipped woodworking shops, but most wet plate photographers don't. And so I started thinking, you know, do I need this giant jig, or could I make a smaller one that I bring to the glass instead of bringing the glass to a huge, you know, kind of stationary fixture? And so then I started thinking about, you know, could I get away with maybe using some just basic aluminum extrusion? And so then I started thinking through ideas for 3D printed designs. And I was coming up with some kind of weird shaped parts that'd be tricky to design, but doable. But the more I thought about it, the more I kind of questioned, well, most of my viewers also probably don't have 3D printers. And so could I simplify it even further, right? Could I get rid of the 3D printed parts and just kind of use standard, readily available hardware? And you can probably guess by the fact that I've gone on this whole digression that the answer is yes. I figured out a way that I could actually do that. And so what I've come up with is a design that requires no special skills, no 3D printer, no woodworking tools, just some basic hand tools, a drill if necessary, and a collection of metric, you know, M3 sized hardware. So let's talk about how this is going to work. What's the principle going to be here? So what I want to do is I want to create a system where we're going to have at least 3 pieces of this aluminum extrusion, and we'll go over what exactly this stuff is in a minute here. But what I basically want you to be able to do is to have this fit and index against the edge of the glass and have a piece on the end, so we can just come in here and use the end piece as a guide to run our glass cutter along the glass and just kind of quickly repeat multiple of those cuts. So how are we going to make this happen? The base material we're going to use here is what's called an aluminum extrusion. So this is literally kind of extruded out of molten aluminum through an extruder that looks kind of like a pasta maker, right? If you ever use one of those, they make these kind of predefined profiles, and they're really handy because you can buy these, right, in a variety of sizes. The specific type of extrusion we're going to be using here is called 1515. So it's 15 millimeters on a side, square profile. And this is basically designed to work with metric M3 hardware, right? So 3 millimeter screws and nuts. There are a variety of kind of makers of 1515 extrusion, and they're all going to have slightly different profiles, right? So this is an LDO extrusion, which you will probably not have any reason to buy, right? I scavenged this from a parts kit for a 3D printer that I never got around to building. You're much more likely going to want to buy from a maker called MakerBeam, which is very readily available. You can find it on Amazon. You can find it on other shops. I know it's available in the EU as well. And I know that this profile can fit socket head screws as well. I'm not sure about the MakerBeam, but any 1515 extrusion, you should be able to fit M3 button head screws and M3 nuts into the channels. So what are we going to do here, right? Let's think about the things that we need. We need, first of all, a way to connect the 3 pieces of extrusion into this kind of T shape, right? Second, we're going to need a way to index this repeatedly against the edge of the glass. And then finally, we're going to need a way to calibrate it to get it to precisely the size that we want. So let's consider those one at a time. And first of all, a note on sizing, right? These are pretty small extrusions. These are going to be big enough to work with 4x5 plates, but I probably couldn't, I might get away with 5x7 with this as well. You could not cut 8x10 with these. These are 200 millimeter long extrusions. But these things are inexpensive and you can get them in a variety of sizes, right? So if you want to break down huge glass sheets, you can buy like 2 meter long extrusions from MakerBeam, and it's not that much money. I think for like $10 or $15, you can get, you know, a pack of 300 millimeter extrusions, which is good for up to 8x10. So let's talk about joining these first, right? I'll set my glass to the side so I don't break it. We're gonna wanna do what's called a blind joint here. And so the idea here is that we're going to take our extrusions, right? These have a center hole that's tapped, so we can screw an M3 screw into it, like so. And so what we're gonna do is we're gonna take our screws, we're gonna slide them into our end extrusion, and then from there we're gonna screw it into our cross pieces here, right? There's an obvious problem, which is how do we turn this screw when the head is embedded in the extrusion? So what we need to do is we need to make what are called access holes. And the idea is that we're gonna cut a hole, or we're gonna drill a hole straight through the center of the extrusion, and that's gonna give us a big enough opening to slide our hex wrench through, and then we can turn the screw on the other side. So you're gonna wanna position these kind of close enough together that whatever the smallest size of glass you're planning to cut is, you will be able to index against them. So you're gonna want basically no farther apart than that piece of glass, than that smallest dimension. And of course you can cut multiple access holes and then move these around if you want, but for now I'm just gonna cut two that are kind of close enough to the center to work with the 4-inch side of a 4x5 plate. These don't have to be precise, right? You can be very careful and measure these out exactly perfectly if you want. Or you can do what I'm gonna do and just kind of eyeball it and say YOLO. So I'm going to, first of all, make a little divot in the channel inside here, just that my drill bit won't walk around when I start the cut. And normally I would do this with a center punch, but because the rail is kind of so narrow here, I couldn't get my center punch in. So I'm just gonna use a regular common nail, and I'm gonna set that roughly in the center of the channel, and I'm just gonna give it a little whack with a hammer. Doesn't need a big whack, just enough to make a little hole. And then I'll put another one in here, roughly centered, give it a little whack. And now there are two little indentations. You may or may not be able to see these on screen, but when I take my drill bit, and if you have imperial drill bits, 1/8 inch is gonna be the ideal size to make an access hole for a 2.5 millimeter wrench, which is what I'll be using for these M3 socket head screws. So I'm going to take the drill bit and I'm just going to find my divot, and that's going to kind of lock into place, and then I'm just going to drill straight through. There we go. Let me clean up my chips. And now we'll drill our second hole. Same thing, we're gonna find our spot, and then we're just gonna drill straight through. There we go. Gonna clean up my work area. I've got some aluminum chips here. And now I've got two roughly correctly spaced access holes in my extrusion here. So now all I need to do is take a couple of these M3 screws. I feed the heads into the ends of the extrusion. And then I can feed my wrench through here. And as you can see, whoops, we'll do it one at a time. As you can see, the wrench will now slide all the way through the extrusion, which makes it easy to find and interact with this screw. So now I can turn the screw with the wrench, and I'm just going to go ahead and feed the end of this other extrusion into the screw. Go ahead and turn that until it's starting to get tight. Then I'm going to set it down and hold it tight against, whoops, lost the wrench there. There we go. I'm going to sit it down and hold it tight against a flat surface to make sure they end up nice and square and flat. Get it mostly tight, and then I'll use the other end of my wrench here. Whoops, don't want to twist it. There we go. To get it very tight. Okay. And if you're going to use a permanent position for these, of course, you can always add a little bit of Loctite to make sure these don't come loose. Now I'll do the second one. Same process as before. I'm just going to slide this in, get it to roughly where I cut my access hole. There we go. We've got it on the wrench. And so now we feed that into the end of our second extrusion. Get that almost tight. Set it down here. Boom. Do our final tightening. And just like that, we've got our T-shape all put together nice and tight. And this, as long as you don't really abuse it, it's gonna stay good and tight for you. So now, for our second task, we need to figure out how we're going to index these against the edge of the glass. So for that, we're going to use these. And I will try to get some B-roll later to show a really good close-up of these. But all we have here is an M3 screw. So these are socket heads. We've got a stack of M3 washers, which are going to create the body that we index against. And then finally, we've got an M3 nut. So the way these are going to go in is you want to stack the same number of washers on both of your screws, loosely screw a nut onto the end of it. And then what we want to do is just feed that nut into the channels on our two cross pieces here. And so these, we're just going to leave finger tight for now because we still need to calibrate this. So we're not going to get these super tight, but we're going to tighten them up enough by hand that they're not going to slide around on us. So these are what we're going to use to index against the glass, and I'm just going to get these kind of wildly wrong to start with, just to demonstrate the principle, right? So I could now take these, and if I slid these both up against the glass, you see we get this wonky angle. And that is, of course, because I have not set them square to each other. If I get them roughly the same distance, then we're going to get something closer to a square guide here, right? And so this is going to, once we get it perfectly calibrated, give us just the right position. Now, strictly speaking, we could use this as is, right? We could kind of set this up with a square and tighten it up. And then all we have to do is use our glass cutter and run it across the end. But I want to make it relatively easy to get this to exactly the right dimensions. And so what we're going to do here is we're going to throw one more piece of hardware in here. And this is what's called a fender washer, right? So a fender washer is basically just a washer that has a really big outer diameter. Now what you would ideally want to use here is, an M3 fender washer with a diameter greater than 15 millimeters. 20, 25 would be great. And what we're trying to do here is to get this to extend beyond the bottom of our extrusion. It turns out really big M3 fender washers are really hard to find. So what I've got here is, I'm not even sure if this is a metric washer. I pulled these off of a pair of kayak foot pegs that I'm not using anymore. But you can use fender washers that are maybe in imperial sizes, and what you may just have to do is add some washers on the outside of the fender washer, some M3 washers to make sure that your screw doesn't slide through. But once you've got that together and you've got it kind of held onto the end of your screw here, what you want to do is you want to come up with a stack of M3 washers that is roughly the same size as the distance from the surface of your glass cutter head to the center of the cutting wheel. So what I've used here, and you may have to be a little bit approximate, but I have used 6 M3 washers. And if I count out 1, 2, 3, 4, 5, 6, we can see what that looks like stacked up next to our glass cutter, right? It's going to get us right about on the same level. And so that means that that amount of spacing will essentially compensate for the distance between the edge of the glass cutter head, which is what we're going to be indexing against our guide, and the wheel that actually does the cutting. So once you've got those put together, all you have to do is slide them onto your end extrusion here. And we're gonna loosen this up just a hair. And we want to get that nut in the channel. There we go. And we want 2 of these, the exact same distance apart. Feed this one in as well. There we go. Get it into position. I'm just going to loosely tighten this down. It doesn't have to be super tight because this is going to be removed as soon as we're done calibrating our plate size. So what we have here is these washers extend just enough past the end of the extrusion that they should match the position of the cutting wheel on the glass cutter. Which means what we can do now is we can flip this whole contraption over, and let's say that I want to cut my 4-inch dimension first. So what I'm going to do is I'm going to take a plate that I know to be the correct size for my plate holder, and I'm just going to butt it up against those 2 fender washers. Now I'm going to loosen up my stacks of M3 washers down here, and I'm just going to butt these up so that they kind of squeeze the plate in between these washers. There we go. In between these washers and the fender washer at the end. Now I don't actually love these washer stacks for indexing because there is some room for these to wiggle and not all be exactly the same distance. So what I would recommend doing here is actually, instead of these washers, I would prefer to use the head of a socket head cap screw. Unfortunately, I don't have any socket head screws that are short enough to rest flush against the channel here. So I've had to make do with these washers. But my recommendation would be get yourself a nice short socket head cap screw and use that instead. But as is, I'll just go ahead and do this. So we can see this is basically held in place. And we've got that nice snug fit between all those washers. So now this, once I remove our fender washers from the end, should give me just the right 4-inch dimension for my 4x5 plates. And there's one final step I want to take before I actually apply this to the glass plate, which is I'm going to take some of this adhesive kind of rubber backing. This stuff was like $10 for, I think, a 12-inch by 12-inch sheet on Amazon. So also fairly inexpensive. And what I want to do is just take this and cut a nice good sized strip off of it. Try not to cut my fingers in the process. Let's see if that worked at all. I don't think it did. I'm gonna flip it over. Might have better luck that way. If you can't tell, I'm building this for the absolute first time on camera and not planning a second take. So if this ends up looking a little bit dumb, so be it. All right, let's see here. There we go. There we go. Let's go ahead and cut this. And now, of course, you want to make sure, oops, razor blade came loose in the knife. You always love that. Okay, now I want to make sure we cut this short enough that it doesn't, it doesn't get in the way of our washers at their shortest position. So this is already at 4 inches, which is the shortest I'm going to go. So I just need to go ahead and cut it roughly about there. Just use the knife there. Take a second cut, roughly the same size. You don't have to be precise. I'm just going to take these and stick them down right here on our extrusion. There we go. And this is going to accomplish two things, right? One, this will help keep the aluminum from scratching the glass. And two, it'll give us a nice grippy surface so the aluminum doesn't slide off of the glass. So now I'm just going to take this and I'm going to make my two cuts here. Here we go. I'm just going to score the glass straight across. And I think this is my 4-inch dimension, yep. And that didn't go well. There we go. Been a little while since I scored glass. Got a good clean break. I think doing this on this narrow board is not actually ideal, but what are you gonna do? This is the situation I've got. Do not copy my glass cutting technique. I'm doing a pretty bad job tonight, but I think that worked well enough. Okay, and now I believe these sides are the ones that are square. This is a little bit of a wonky off-cut piece of glass. So now I'm going to slide my fender washers back onto the extrusions here, and I'm going to adjust my jig for the 5-inch dimension. Now, of course, if I was cutting a bunch of glass, I'd want to cut as many strips in one dimension as possible with the same setting, and then I would switch it up. For the next size in line. Another option, since this extrusion is not particularly expensive, of course, is that you could always just have multiple of these jigs. There's no reason that you have to have one and keep adjusting it back and forth. You could have, you know, one for 4 inches, 1 5, 1 7, 1 8, 1 10, and just swap back and forth between them as you're prepping your glass plates. That is always an option. Costs you a little bit more in extrusions, but it would save you the hassle of adjusting these every time that you wanted to change sizes. So what I'm saying is you got options. And so now I'm going to adjust this to the 5-inch size. There we go. Okay, let's take our fender washers off the end. And let's make some cuts. I'm going to go ahead and bring this over here. Just cut it against the table so I got better support. Here's our first 5-inch cut. And here's our second 5-inch cut. And because this is the first time that I have built or used this tool, I really hope these are coming out the correct size, because if not, I'm going to have to redo this entire video. So let's take our original template plate and look at that. It is pretty much a dead-on fit. So we're off by maybe like a 1/2 millimeter or so because those fender washer stacks weren't precisely the right match. But this is really, really close. Close enough that we should have no problem at all fitting this into our plate holder that fit the original plate. So there you have it. And yeah, this is ever so slightly bigger than the original plate, so it's a little bit tight, but overall, a very, very close duplicate. Good stuff. Yep. Maybe a hair wide. There we go. No, no. Yeah, it barely fits. So be careful with the sizing of your fender washer stacks, and don't be afraid to go a tiny bit smaller if you have a Chamonix holder like mine. But yeah, the basic principle seems to work fine here. We've got in total, I think about $20 worth of parts here. You know, if you were to buy kind of multiple extrusions in this entire sheet of rubber adhesive. So this is a fairly cost-effective, very easy to use, very easy to kind of just repeatably go through and make cuts, right? I can take this to a large sheet of glass, or as large as I have a cross section for, and I can just keep buttoning this up and making cuts over and over again. So hopefully that proves useful to you. I think that wraps us up for today. I'm gonna record a little bit of B-roll footage so I can get in some close-ups of the various parts of this thing and kind of splice them in there while I'm talking you through it. But yeah, hopefully that has been a good overview. And if you cut glass and you want to give this a try, let me know how it works out for you. And with that, happy shooting, and I will see y'all next time around. Okay, good stuff. How long was that? That was about 34 minutes. Not too shabby, not too shabby. All right, so let's get some B-roll here. I started thinking, you know, do I need this giant jig, or could I make a smaller one that I bring to the glass instead of bringing the glass to a huge, you know, kind of stationary fixture? And so I started thinking about